All right, folks, here's what we're going to do today. We're going to cover more on two-dimensional motion. I'm going to derive for you a pretty important equation. It's called the range equation. Although, remember I told you, which equations do I want you guys to know for this chapter? Which equations do we need to know for last section? It was, all we needed to know for last section was the V final equals V initial plus AT. We need to know delta x equals V final plus V initial divided by 2 times t. We got our favorite one, delta x equals V naught t plus 1 half AT squared. And we got V final squared equals V initial squared plus 2a delta x. Are we cool with that? Those are the four basic ones. And then I told you yesterday, or I told you the other day, hey, guess what? You don't need to learn any other equations. In order to do two-dimensional motion, you just need, the only thing you really change is you change these x into y's when you're talking about the vertical direction. You keep those as x's when you're talking about the horizontal direction. And then I usually put in a bunch of subscripts on here just so I remember which direction I'm talking about. But for the most part, you don't need anything new. So I'll tell you what, I'm going to do a quick review of how to solve a two-dimensional motion problem, the one that we did yesterday, or the one that we did on Thursday. And then I'm going to show you folks a little bit about this thing called vectors. This is a super important topic that you might not have seen before in your previous math class. I have a question. I'm just curious to know. Have you guys used quadratic equation? Do you guys remember that one? Alright, so you've seen quadratic equation. We've got, and I noticed that one of the students came up to me and says, I don't know how to solve this one problem. And I said, use quadratic equation. And he looked at me and was like, what is that? And I was like, well, really? You didn't know quadratic equation? But that's kind of an important one, so keep that in the back of your head. And then also, have you seen sine, cosine, tangent before once in your life? Where did you see it? You saw it in algebra, some of you saw it in trig, some of you are taking trig right now, so obviously you won't be seeing it just yet. But that's what we're going to show you. Anyway, let me do my quick segue. It's my quick review. I've got myself a cannonball, and I'm firing it straight horizontally, velocity initial, in the x direction. And remember, what is the process? And this is how do we figure out, what I want to do is I want to figure out the range. Range equals what? And therefore, and I know the height. Height is h, I also know gravity. And what I want to do is, the process was look, and actually, you know what the process was first? Break motion into two different directions. Got it? And those two directions being x and y. The first thing we're going to do is look in y direction. Look in y direction. And figure out how long it takes. How long in the air. We cool with that? I want to break it up into two directions, x and y, and that's actually pretty easy because initially it's only going in the x direction. And in the y direction, I want to figure out how long it's in the air. Alright, I'm not going to go through the whole thing slowly with you and ask you everything. I'm just going to start running through this because I went over this in detail on Tuesday. But remember, okay, so velocity initial in the y direction is 0. Acceleration in the y direction is positive g. And that's because this is my coordinate system. I've got x and positive y going down. My acceleration in my direction is positive g. My delta y is actually h. All right. Good catch. But here, check this out. I'm calling things going in the down direction positive. Does that freak you out? If it does, yeah. Okay, I'll tell you what. That's a good valid thing to be upset about. And I'll tell you what I'll do is I will I'll call this positive direction up. just so that I don't freak you out, Tiger. In this case, it would become negative g. Do you agree? Okay, but my delta h is what? My delta y. Right. The final position is down on the bottom. The initial position is higher. And if it's final minus initial, it's final, which is a small number, minus initial, which is a bigger number, it's going to be a negative h. Do you agree? And you're going to see that those cancel out. All right. And then my time is what? I don't know. My velocity final is dk dc. And so I actually, the way I choose this is I say delta x, or in this case delta y, equals d naught in the y direction t, plus 1/2 gt squared, or no, at squared, and that's in the y direction. Now plug in my variables, and I got negative h equals 0 minus 1/2 gt squared. Yeah? This negative cancels out with that negative. I'll give you a hint. If you were to call, like I previously did, positive y, then it would start off as positive h, and it would start off as positive g, and that would still give you the same mathematical expression. Which is pretty cool, because the math kind of fixes itself. Alright? Now I'm going to solve for t, and I end up getting t equals the square root of 2h over g. Is everyone cool with that? Yeah. Okay, brilliant. Don't just nod your head and say, yes, I'm cool with that, unless you're actually cool with that, because I know I did a few steps in my head, but I mean, you keep telling me that, oh, you know, I'm fine when I'm watching you, and then when I go home and try to do it, it's just like, what do you do? So make sure you guys let me know if you guys need help. Anyway, I solved for the time, square root of 2h over g. I know my units are going to work out. And then the next step that I did was I said, all right, now I'm going to look in x direction. And I'm going to say during that time, how far? So during that time that I calculated, how far did it go? And the way I do that is simply figure out my variables. V naught x equals V naught x, well, I mean, whatever it is. Your acceleration in x direction is 0. Your delta x is equal to r, and that's what we're looking for, right? Your time is equal to the square root of 2h over g. And your v final, you don't know, don't care. So I've got delta x equals v naught yt plus 1/2 at squared. If this is 0, and so I end up getting r is equal to v naught x. I'm sorry, that's supposed to be an x. V naught x times the square root of 2h over g. Are we cool with that? Okay. Alright. Is everyone good then? I can move on? This is what we did on Tuesday. So, check this out. We are doing now two-dimensional motion problems. And the way we're doing this is we start off by breaking it up into its different directions. However, not everything goes only horizontal. You know, you don't always fire bullets horizontally. Right? Would you agree with that, Austin? Like, I would like to be able to raise my rifle up and down at different angles. And if that's the case, how do I break these things up into the directions? And in order to do that, we use this trick called trigonometry. Now, I'm going to show you a little bit of trigonometry first, because I keep promising you that I'll teach you. So make sure you write this down if you've never seen it before. If I have a triangle, got it? And I know the angle is theta. Then there are different parts of this triangle, and one part is the hypotenuse. I'm going to label it height. You guys got it? Define the hypotenuse for me. Come on, you guys, tell me what the hypotenuse is.
A squared plus b squared equals c squared.
All right, fine.
No, well, okay, fine. A squared plus b squared equals c squared. You're talking about c being the hypotenuse. What is the hypotenuse? The hypotenuse is the longest side of a triangle. This only applies to right triangles, of course. It's the longest side, and it's also the side that is across from the 90-degree angle. Is everyone cool with that?
Yeah.
Now, if this were theta down here, what side is this? Is what side is it in relation to theta?
The opposite side?
It's the opposite side. Is everyone cool with that? Yeah, I'm going to label that OPP. In fact, are you good with that? Are you down with that? You got it? You guys aren't catching my joke. You guys are born in like the 90s, so I mean, you probably won't catch my joke. But it's like, you got OPP, yeah, you know me. That's what you're supposed to say. Anyway, if you're born in the 80s, you would know what I'm talking about. All right, it's a rap song. Anyway, this side over here, what does the word adjacent mean?
It's adjacent to angle. Right next to it.
What adjacent means is next to. So there are two sides that are next to the angle. But one of those sides that is next to that angle is called the hypotenuse. So the other side is called the adjacent side. Does that make sense to you? We good?
Yeah.
Now,
The only thing I would have to warn you.
against is be careful because the adjacent side isn't always the one on the bottom. For example, if I did this, then this would become the hypotenuse. This would not be the adjacent. This would be the opposite side, and this would be the adjacent side because I defined my angle up here. So this is all relative to where the angle is, what angle it is you're talking about. Does that make sense? All right, cool. Then let's do this. I'm going to erase this. And we'll get started on this thing right here. All right, so check this out. What's going to happen is this. We're going to define some kind of trig functions for this. And I'm not going to go into like the history of them. That's for I'm going to leave that for your math class. What I'm going to do is I'm just like quoting stuff for you. But I want you guys to learn this phrase right here. SOHCAHTOA. Already you know how to chant it. What does SOHCAHTOA mean?
Opposite hypotenuse.
There was a sign.
Cosine is adjacent to hypotenuse.
Okay, wait.
Before you, Tiger, you're going off on this thing. But what you have to say is sine of theta is opposite over hypotenuse, right? The cosine of theta is adjacent over hypotenuse. And the tangent of theta is the opposite over adjacent. Are we good?
Yeah.
Now, I got a question.
Answer now or forever be confused. Is there anyone who hasn't seen this before?
Okay, then that is your one chance for to tell me to let me know whether or not you've seen this before. Now, I admit maybe you don't know how to apply it, so let's try applying it. Say that we have a line that is at angle, I don't know, 20 degrees or something like that, right? Say that we have a ladder and we're leaning up the ladder, it's 20 degrees. The ladder is 8 feet long. Cool? And in order to get from here to here, I would either go 8 feet in the 20-degree direction, or I could tell a person to go,
So many feet to the right and so many feet up, and I would end up at the same point. Does this make sense to you so far?
So the question I want to ask
Is if this were a vector, I don't know, k, then what is kx and what is ky?
kx being the x component of k, and ky being the y component of k.
So here's how you do it. If you have the hypotenuse 8 like that, and you got 20 degrees here, and you want to figure out what this side is, let's call it A. Why would I call it A? Because it stands for the adjacent side. Which trig function can I use that will relate A to theta to the hypotenuse?
Sine?
The sine deals with the opposite and the hypotenuse. I'm not talking about the opposite, I'm talking about the adjacent side here.
Oh, you're doing A?
Yes, A.
Cosine.
Cosine. Exactly. The cosine of theta equals adjacent over hypotenuse. So all you're saying is the cosine of theta is equal to A over 8. Agreed? And if I ask you to solve for A, what is A? All you do is A equals 8 cosine theta, which is A equals 8 times the cosine of 20, and you plug that into your calculator. And by the way, you need to make sure your calculator is in degrees mode for this particular problem. Degrees mode. Alright, the way you find that is there's a button that says mode on your calculator.
I've got 7.5175.
7.51. I can agree with that. I can hang with that. Are we cool?
Did everyone get 7.51 on their calculator? If they didn't, then they used the wrong mode. I want to make sure everyone got that, though. Let me know.
I did.
All right, cool?
Got it.
Okay, good. Good, good. It sounds like you guys know how to use your calculators. That's pleasing to me. All right, let's figure out what O is. If I have, now I'm dealing with, I want to figure out what O is, and I know theta, and I know 8. So I would argue that I can just use sine of theta equals opposite over hypotenuse. And if I want to figure out what O is, that's not a 0, by the way, that's an O, then that's h sine theta, or 8 sine 20, which is what? Which is? Come on, folks, I don't have a calculator on me.
So, it's 7.51.
Really?
Oh, wait, no, that's cosine.
Yeah, I want the sine. I'd imagine it's going to be something small, like maybe 1.
2.73.
2.73.
2.74.
2.74. Does everyone agree with that?
Yeah.
Okay, so check this out. Look, imagine that I have Mr. Boy Scout here, Mr. Dude, I got a question. Austin, you're so into the military. Were you ever a Boy Scout?
Oh, no, I was never Boy Scout.
Oh, okay. All right. Do you know how to read a compass and a map and that kind of stuff?
I do.
I'd imagine you would. Is anyone else here a Boy Scout? Or a Girl Scout? No one, huh? Huh. All right. All right, so imagine I have this. I'm standing in a forest, and the map tells me to walk 80 feet, 20 degrees, 20 degrees north of west. Okay? But here's the problem. There is a bear right here. Rawr. And he has sharp teeth. And he will eat me if I walk that way. So, what you could do is you could replace that 80 feet at 20 degrees northwest. Apparently, you can replace it with, all right, fine. Then walk, I'm sorry, this would be north of east, isn't it? Sorry. Then I want you to walk 75.1 degrees east, 75.1, and I want you to walk 27.4 feet north. And you will get to the same spot as if you were to walk 80 feet at 20 degrees north of east. Does that make sense to you? I've taken my diagonal. I've taken my vector that is a diagonal. It has a magnitude and a direction. It's a vector. And I've broken it up into a horizontal piece and a vertical piece. And I can replace that diagonal vector with two vectors that are broken up horizontally and vertically. And here, I'll show you a cute little thing over here. Let's grab one of these. We'll throw her in there. I want the radius to be 8. Tell you what, I'm wondering if no, I can't. Never mind. I want the radius to be 8. That's about 8. And I want it to go to about 20 degrees. 20 degrees, up 20 degrees. Okay, let's see if I can get close to 8. There. No. It's hard to do this, actually. Alright, that's good enough. Okay, so check this out. What I'm going to do is I'm going to show the sum. Whoa, what? I forgot. Oh, okay, here we go. Oh, this thing is on a grid. It's hard to... All right, let's go 80. Let's see if 80 works. Okay, let's see. Oh, whoa, what happened? Oh, the thing doesn't work very well. All right. Let's go 80. I'll go 20 degrees. Oh, I almost got it. Hold on. Should have chosen better numbers. All right. Basically, this thing would do the same thing where, like, let's say I had 70 degrees or 70 feet and 21 degrees. Essentially, it's saying in the RX direction, go 66 feet, and the RY direction is it goes 26 feet. And I can replace those two. I can replace this. Actually, you know what? Let me do this. Style 2. Yeah, that's perfect. And I don't want this one. I can replace this one red vector with these two pink vectors. Does that make sense?
Yeah.
Okay, good. Then you guys know how to do this. And essentially, that's it. That is the hard part about two-dimensional motion. Once you get that, you've gotten two-dimensional motion. Let me show you how we do it. And I'm going to start off with one of these standard problems. It's called the range equation. It's called the range equation. However,
I do not recommend that you memorize the answer to this equation. This is a range. It's called a range equation. It's not really an equation. It's not one of those things that you have to memorize. It's just a very, very standard problem that we always do to start off our physics students. And what we did is, let's say we have a cannon that is being fired here. You shoot it off at an angle theta. Got it? How far does it go? R equals what? So my thing is going to look like this. How far does it go in that time? So let's try it. Alright, let's not be words about it. What I'm going to do is, I know its velocity. The velocity of the cannon is v naught. We cool?
Yeah.
Alright. I also know what I do immediately when I see v naught, I think of, when I see a vector that's at an angle, I immediately break it off into its components. Because what I'm going to do is, what we do in two-dimensional motion is we don't take into account two-dimensional motion altogether. That's too confusing. What we do is we break it up into its x direction, and then its y direction, and then we apply our principles of one-dimensional motion to that, which makes it a lot easier. So let me explain. I'm going to figure out what is v naught x, or no, this would be v naught y, and what is v naught x. So what is v naught y and what is v naught x? Well, in order to do that, I need trigonometry. So, if I've got a triangle, theta, here's v naught, then what is the opposite side? Which trig function should I use, my friends?
There we go. Sine of theta is equal to this thing, which I'm going to call that V naught y over V naught. So therefore, V naught y equals what? V naught times sine of theta. Are we cool? Alright, so this is equal
to V naught sine theta. Alright, what about the x direction? Well, let's do it. I'm talking about the adjacent side this time.
time, not the opposite side. So which trig function should I use? Breland, give me the answer for that one. It's alright. Cosine theta, which is equal to V naught x over V naught, and therefore V naught x equals V naught cosine theta, and that's it. Now,
how do we solve this problem? Well, we do the same exact process that I showed you earlier. We break it up into two parts. We did that. We broke it up into two components. After that, we look in the y direction and we figure out how long this thing is in the air for. And then after that, we're going to figure out how far it goes during that time it was in the air. So, in the y direction, my velocity initial in the y direction is v naught sine theta. My acceleration in the y direction is what?
my acceleration is
Rhymes with he. Starts with a g. G. What? Yeah. Negative g. There we go. All right. What is my delta y in this case? Think about this one. Nope. That's delta x. That's a range. What is my delta y? Someone said 0. Who said that? Austin. Why 0? What? Why 0? Right, exactly, because we're talking about the height final minus the height initial, and they both landed at the same exact height. And so therefore delta y is 0 in this case. And what is my time? Well, that's what I'm looking for. What's my velocity final? We almost never care about that. Which equation we use? Delta y equals v naught y times t plus 1/2 at squared. That's ay. So this would be 0 equals v naught sine theta times t minus 1/2 gt squared. Are you confused yet? No, of course not. Alright. I want to solve for t, right?
Wait, can you explain the formula again?
This formula?
Yeah.
That's the third formula. That's the delta x equals v naught t plus 1/2 at squared. But I'm doing it in the y direction. Does that make sense?
Yeah, I think so.
When I'm doing it in the y direction, I make sure, and all I'm doing is I'm changing notation here. I'm saying instead of delta x, I'm using delta y.
and instead of V naught, I'm just plain old
V naught. I want to make sure that I remember, hey, I'm doing it in the y direction, that's why I put a v naught y.
And instead of just a regular A, I put an A sub Y because I remember
I'm talking about the y direction.
it helps me remember to do this.
Alright, I'll solve for t. One of these t's cancels out with the other t. Are we cool with that? And then therefore, t equals t equals 2 v naught sine of theta divided by g. Let me just double check to make sure the units work out on that. What's the units for 2? Nothing. What's the units for velocity? Meters per second. What's the units for sine of theta? You guys know? Sine of theta doesn't have units. It is also just a number. So, no units from there. What's the units for gravity? Meters per second squared. Let's see. That's the same as meters per second times seconds squared over meters. Meters, seconds, seconds. I'm left with seconds. Is that a good thing?
All right, so
That's my time. That's the time that I'm in the air. Now, I'm going to take my next approach. Next approach is saying, all right, now that I have my time, let's figure out how far did it go in that time. Does anyone have any questions about what I did? Did I do my algebra too quickly for you?
No.
All right. Now let's do this. I'm going to talk about the x direction now. And I'm going to do the same thing. During this amount of time, which I can calculate out, I mean, if I gave you numbers, then you can plug those numbers in and you can figure it out. But during that amount of time, how far did it go? Well, let's figure that out. V naught x is equal to V naught cos theta. Everyone agree? I got that from there. My delta x, what is that equal to? It's equal to r, which is what we're looking for anyway, so we don't know it, but we're going to call it r for now. What's my ax?
huh? What is my AX? Rhymes with hero.
0, there we go. My acceleration in the x direction, it's because gravity is only pulling in the y direction, not the x direction. Alright, what is my time? Oh, my time is 2 v naught sine theta over g. And so therefore, let's plug it into our standard equation that we always use because our v final is our dk/dc. Don't know, don't care. So therefore, delta x equals v naught t plus 1/2 at squared, and therefore r equals v naught cos theta times t. Do you agree with me?
Yeah.
Because this went to 0. Because ax is 0, by the way. Alright, and then all I do is I plug in for t, and therefore my range is equal to v naught cos theta times 2 v naught sine theta all over g.
And this, my friends, is the range equation. Your range equation is actually v naught squared times 2 sine theta cos theta all over g. Do you believe me?
Yeah.
Yes, of course you believe me.
Yeah.
I'm your teacher. But let's check the units. I wouldn't believe me either. Check the units. The velocity initial is meters per second, but I'm squaring that, so it's meters squared per second squared. 2 sine theta cosine theta is no units whatsoever, and this is in meters per second squared is gravity. This guy cancels out with that guy. This guy cancels out with one of those guys. I'm left with meters. Yippity-doo-dah day. That is what my range is supposed to be measured in. Meters.
So I'm just wondering,
Yes, sir.
how come we put I'm just wondering, the v naught squared in front of the 2? I'm just wondering. Higher.
Just because I like combining the like terms. Because I'm multiplying all of this stuff. I'm multiplying v naught times cosine theta times 2 times v naught times sine theta. I can rearrange it all out anytime, any way I want.
Alright.
In fact, you guys, who's taking trig here?
I am.
You're taking trig? Who's taken it already? Allison? Have you taken trig?
She's giving me
Oh, what happened? All right. If you've taken trig, you're going to learn this thing called it's just an identity. And it's called the double angle identity. It says that the 2 sine theta cosine theta is the secret code for sine of 2 theta. If you don't believe me, let's look it up. I'm going to show you guys one more thing, and then I'll be done. But let's see the trig identities, double angle. This seems like a good place to go. SOS math. It's the help math. Check this out. Sine of 2u equals 2 sine u cosine u. So that's exactly what I was saying. The sine of 2 theta equals 2 cosine or sine theta cosine theta. So really the range equation that you usually see, that we are used to showing people, is this. R equals v naught squared sine of 2 theta divided by g. That's the range equation. Now let me show you some cool stuff. Let's choose some numbers here. What's the velocity that we're going to talk about here?
Choose a velocity for me. V naught equals what? 80. We're shooting something off at 80 meters per second.
What's gravity?
9.8.
9.8 meters per second.
Second squared. What is theta? How?
At what angle would you like to shoot this at? Let's make it 30. How's about 30 degrees, all right? I'm going to choose that one. All right, here's what I want you to do. Figure out what is R equals 80 squared times the sine of 60 degrees divided by G, or divided by 9.8. By the way, why did I use 60 degrees? No, because I'm talking about 2 theta. Yep. All right, so let's figure that out. In fact, I'm going to use Google to help me out with that. 80 squared times the sine of 60 divided by 9.8. And you know what? I want it in 60 degrees. Because Google likes to do things in radians. I got 565 meters. Is that what you guys got?
Hold on. Got it.
What'd you get?
Got it.
565?
Yeah.
All right, check this out. We're going over to this simulation right here. Here, I'll chat it over to you guys. Hey, what's going on, Scott? I didn't even see you come in. All right, so I chatted this over to you. I'm going to put in the parameters here. I'm talking about shooting something at 80 degrees. Or no, I want it to go 30 degrees
30 degrees.
at a speed of 80. The mass and the diameter. Notice how the mass and the diameter didn't come into thing. And I don't want air resistance. Let's fire it. All right, it's going. It's booking it. There we go. There we go. There we go. Bing. 567.6 meters.
How did we get that too long?
How did we get 2 off? Well, it should be 566. And I think that, to be honest with you, I think they're wrong. Let's see. Would changing the mass do anything for that? No, not really. It looks like it's going the same exact path. I think they're wrong. Oh, I know why. Because the height is negative 1.2. They didn't start the height at 0. Their cannon started higher. Their cannon started 1.2 meters off the ground. Does that make sense?
Yeah.
Because that's why in the end you saw negative 1.2. Because their cannon started off 1.2 meters off the ground already. So it ends up negative 1.2, and we didn't take that into account. And this is why I'm saying don't memorize the range equation. It's a very common one that we show you. However, it's not the it's a common one that we show you. However, it only works for the scenario that delta y is equal to 0. That your projectile lands at the exact same height as it starts. Now that's pretty common. Like when you're playing football, right? You are playing football and you're a quarterback and you throw the ball and you want to get it to a receiver over here. That receiver is about the same height as you are, as the quarterback is. So therefore, they catch it at about the same height that the quarterback throws it. So therefore, the range equation actually works fine. And this is not what professional football players do, but I mean, if we wanted to calculate out how to get them to to do that, then we can figure out what to do. Or if you wanted to launch a big bullet over at something which I know Austin's kind of into, then you would and you could change like the angle that you shoot it off at. Then you would plug in different angles there and figure out, well, which angle will give me the correct range. I mean, we're literally solving out your sniper problem right here for you. Is that pretty cool or what?
Yeah.
All right, next time we meet up, I'm going to show you how to mess with this thing. But for the most part, that is two-dimensional motion, my friends. And the real complicated part, the trick to it all is this. How do I break it up into 2 dimensions? And would you like to know how to break it up into 3 dimensions? You just apply SOHCAHTOA again, and you get, and in that case, you'll have a V naught Z. So you have a V naught X, a V naught Y, and a V naught Z. And then you do the same thing. 3-dimensional motion isn't harder than 2-dimensional motion. It just takes one extra step.
Which one would you use? Cosine theta, sine theta?
Well, that one, all right, I'll admit, it is a little bit harder because you're going to talk about 2 different kinds of angles. And usually we call those 2 angles theta, and the other angle we call phi, which looks a lot like theta, but it's just a different direction in the line. So theta goes horizontal, phi goes vertical. And then that's when you're describing, 3-dimensional motion. But for the most part, in the introductory physics course, we don't bring you beyond 2 dimensions. We just do 2-dimensional, pretty much everything. Everything is 2 dimensions in physics for the introductory level. For the big kid physics, then we're definitely going to talk about 3 dimensions. Are we cool?
Yeah.
Well, then that's it. I mean, to me, it was really exciting. I was really excited about that. But anyway, here's your range equation, which I would not recommend you memorize. I would recommend you memorize these equations up here, particularly this one, and the process to solve out these types of projectile motion problems. We use the same exact process here. Are we cool? All right, the next time we meet up, I'm going to go over a bunch of example problems, but for the most part, I think I'm done. Does anyone have any other questions? Scott, you good? Scott?
I'm good.
All right. Breland, how we doing? How's your brain? Trevon? Breland, are you good? You understand?
I got it.
Yeah.
All right.
Yeah.
All right, good. Then the next, I think that I have a problem called the crazy insane water slide, and I'll go over that type of problem with you later. But I mean, all it is this: you get launched off of a thing at an angle. How far do you go? I think with the crazy insane water slide, though, it doesn't land at the same exact height that you started at.
Use the range equation.
So you can't straight up use the range equation, but I'll give you your hint, is you can use the exact same process as what I did here. You can use the same steps for solving that problem as well. It's the same steps that I did on Tuesday, it's the same steps I did on Thursday. The only thing that I can think of that I can really throw in there that will complicate things for you is the quadratic equation. The quadratic equation is going to appear, its ugly head right around here. In this step right here, I've engineered the problem so that, you can simply just straight up cancel out t's. But in one of your homeworks, you couldn't do that, and so you had to use the quadratic equation. Well, that's why I made you do that homework set, so that way you get used to doing the quadratic equation. Are we cool with that, folks? If not, if so, I'm going to go and have a wonderful weekend. I'm going to work through grading a whole buttload of homework, and I'm going to assign some more homework for you.
Okay.
All right.
Alright.
Have fun.